This is Durga Prasad from AID Hostlers. Now I am going to tell about a topic called pass tree from compiler design. So pass tree is the diagrammatic representation of the diagrammatic process of a context-free grammar, where the pass tree contain three major rules. Where the the first rule is root node should be a start symbol, and the internal internal node should be a non-terminal, example a variable or any uppercase letter. And then coming to third rule, the leaf node should always be a terminal. So by using these three rules, we are going to construct a parse tree to a given grammar where E tells to E plus E, or the grammar E tells to E into E, or else E tells to E parenthesis of E, or else E tells to ID. Now, the parse tree can be represented in two ways. One is left derivative part and the right derivative part. Coming to left derivative part, so I am going to construct a parse tree for the given grammar, and the string is ID plus ID into ID. Now I'll take the starting grammar as an input, where E tells to E plus E. So as it is a right standard tree, now I should start from the left standard tree. I should start from the left side. So the first symbol is E. So to get the string as an input, now I am replacing E in place of E into E plus E. So coming again to the left tree, so E I replace with ID. So I'll get the first element in my string. So next, again, I replace E with ID in the second step. And in the third step, I replace another E with ID. So this is how we form a transaction function using a left standard tree. So coming to right standard tree, I'll take the same symbol as an input. Now I'll start forming this from the right side. The left E remains same and the right E becomes E into E. And the third step, again coming to right side, this E becomes ID. And next this E becomes ID. And at last the left E becomes ID. So this is how I gain the string using a transaction function using right standard tree. So now drawing a phase tree from less standard functions is E is divided into E plus E in the first step, and the left E is further divided into E into E in the second step. And in the third step, the first E is divided into ID. And in the third step, the next E is divided into ID. And in the fourth step, the last E is divided into ID. So this is how we call it as the yield of the program, which actually means that it calculates all the last nodes of a given parse tree. So combining all the yields I got, so by using a left standard tree, I created a pairs diagram which is equals to the given string that is given in my question. So same, I am drawing a tree for a right standard tree. So again, taking E plus E as my first node. And in the second step, I neglect the left E because as it is a right standard tree, I need to start from right. So the right E is further divided into E into E. And again, the right E is further divided into ID. And the next E is further divided into ID. And the last T is for the divided into ID. So taking the yield of the string will give me the same result, ID plus ID into ID. So this is how I got this string. So this is how we need to solve a problem when a given grammar and string is given, and we need to draw a left standard tree and right standard tree along with their parse diagram. So here we cover another topic is called ambiguous grammar. So a grammar is said to be an ambiguous grammar when it satisfies both right standard tree and standard tree, which actually also means that if any grammar is can able to draw or can able to implement two path trees, it is known as ambiguous grammar. So this is how we denote a given grammar into a parse tree. Thank you.